Okay, so this is basically just a way how to make any 3D design. You start with a 2D canvas, you make a projection first, and then now you see I don't draw the circle and then try to draw something else there. So later on, when we done this on the 2D sketch, we can create like 3D object by increasing the height of that. When you are in the SolidWorks or 3D Fusion, so the format is different. You need to change into format that can be read by the 3D printer in order to print this. This is slicer, slicer, slicer. The purpose of slicer is to slice your digital artwork into layer by layer. Put in the slicer, so you get something like that. Okay, so this is chest set. So we need to sort of like we need to make sure this is on the bottom lah. If you print like this, there will be hanging thing. You can see that. How can you print on the air? Because we have layer by layer, they will start at the bottom right. So you need to reorient this so that we can make this as a that. Okay. So now this start with the one layer. They add until you get the full chest set. So this is layer by layer production of 3D printed object. Okay, so now I have this. So this can be read by the 3D printer.
Okay. Hai. Sini. Gimbal ni. Oh. Di atasnya ni gimbal, bukan gimbal. Okay, understood. Hai. So hari ni kami akan pergi ke lab Dr. Wan. Jadi let's go. Let's go.
Okay, now I already put the Inol chest set inside this SD card. So I go to print from SD. So this we move like this. I mean different printer have different way lah, So print from SD and I see Inol there. Here, Inol mana Inol? Inol chest set. So let's say I go to Inol. Tekan. You buat tekan. Okay. Now they start to draw the Inol, the first layer of I call it the first layer of the circle. So if you look here, they tell you how many minutes left. So they have 10 remaining minutes. Okay, I think we can do those. So later on we will do the white lah. Okay, so now while doing this thing, let me show you the example here. Now I want to tell you what's the advantage of using this 3D printing. One advantage of 3D printing, it can produce object that is not possible to be manufactured using traditional method. That's a complex thing. Second, for the teaching purpose, you can do it custom made. For example, like this. Let's say you have this Falcon cube. You cannot override. So you can create your own design and then you put it there. Okay. So that's one of the advantage. You can custom make rather than you need to order from others and so on. You can make yourself. You learn about CAD, you can buy this 700 ringgit and then you can just put that. Not this right, this is 4,000. But the cheap one, they are like 700 ringgit. Okay, and next you can also make assembly. You can make assembly. Later on you can touch lah. Okay, sekarang ni dengar dulu. Okay, you can make assemble. For example, you can make like a functional thing like a screw like this. And then you can also make a toys. Okay, so this assembly, meaning that you not, because this is one piece. This is assembly, meaning that I make it part by part. Okay, like that. So you can just take it out and so on lah. Okay, so you can design whatever you want and do whatever you want lah using this thing. Okay, and so on. And another advantage of 3D printing is that, let's say in class you learn organic chemistry, right? This is what? Yelah, item apa benda ni? What is this? Black is for carbon. White is normally for hydrogen. So this is what? Methane. This methane. Organic chemistry by putting kan. This methane. So sometimes in organic chemistry during the reaction part, Dr. Murila, I don't know whether he will teach or not, she will teach or not. There are something what we call when you do nucleophilic attack or nucleophilic attack and so on. You want to show the intermediate. Let's say you want to show something goes into this atom. But of course, when you buy this, I buy from the Shopee. Okay. Normally, when you buy from this what I call organic molecule teaching material. When you buy, the carbons always have 4 holes. 4 holes. There are no seller sell you the carbon with 5 holes. So you want to teach to your student that there are intermediate where there are somehow they are like another atom attached here. Okay, so during nucleophilic attack and so on. So you cannot teach using this because this is like a normal and stable method. So you can create your own like this. You can create your own the carbon, the black one. I create your own, so then you can make a hole and so on. So this is useful when you want to make a props or teach something that is not possible using that is commonly sold molecule lah. Like this, so you can make 5 hole. So normally carbon attached only 4, right? But this you can show the effect of intermediate, what happened during this, the steric effect and so on. So that's another advantage of learning 3D printing. This is wood filament, meaning that you see this is plastic. So they infuse with some wood. So the smell also like wood. I don't know this long time ago. I don't know the wood smell is not there anymore. But basically this filament they combine with wood powder. So that's why you get this wood-like sample object. So this is example. Whatever you see just now here, inside that's what we call infill. Remember the term infill. 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 So normally when you print 3D object, you don't print full because it will just waste the material. Imagine this is full with the plastic. So it will waste material. So normally they just put the skin outside and the inside they are hollow. So to conserve some material. Okay? So this is what you call infill. So you can make a different infill have different strength and so on. Of course, 3D printing able to print very complex object. But there are things that is very challenging even for 3D printing. For example, let's say you print from the bottom. So in order to print on the top here, the nozzle there will hang on the air. So for example, to print this is easy because whatever the second layer will have previous layer on top of finish there. So they have support on the bottom. So to print the next layer, they have support on the bottom. But here you can see this thing, the nozzle will print on the air. So this is what we call the overhang. So the good printer can sort of like print very thick overhang. I need to print like this from this configuration. I need to orient this thing like this. I cannot print like this. If I print like this, there will be overhang, meaning that the nozzle doesn't have place to sort of like to support lah. So this is what we call overhang lah. So normally the 3D printer can print at 45-degree angle is still okay. But if you do like 90 degrees like this, right? You print bottom and then at the here there is 90-degree curve, not curve but angle there. So the nozzle doesn't have place to support. Right. Here you can support each layer, support another layer on the top of it. Okay, so this is Inol chest set. But if you look at this closely at this chest set, datang dekat. Okay dah. Datang dekat. You nampak tak cantik kan? It's not really nice. This is example of no matter how good your 3D printer, your starting material matters. Because if your starting material is not good, then the result also have some defect lah. Tak ada luang. Tekan sikit. Dia akan masuk. Okay. Dia masuk tak? Rasa dia masuk tak? So now, the nozzle here typically made from brass. From brass. B-R-A-S-S. The nozzle here normally made from brass. This is PLA. This is normal plastic. Plastic that is nothing. They are not really challenging for this what I call this brass or metal. But if you have something, let's say the wood, okay, PLA plus wood. This is PLA plus wood, meaning that you have this filament and then you put in some wood particle. So that wood particle, when it coming out here, it will sort of like become abrasive. It will sort of like wear and tear this thing. So over time, if you keep inserting a lot of wood particle or any carbon fiber, whatever composite polymer, so this thing will be wear up lah. So that's why sometimes people use this Olson rubbing. This is nozzle, but on the tip there they use what we call the gemstone. We call it ruby, R-U-B-Y. Oh, ruby. Delima, ruby. This is real ruby lah. Okay. Of course, the cost is much higher than this lah. This around 400 ringgit. This around 5 ringgit only. Okay. So because the reason why they use this gemstone, because gemstone is a mineral, it's ceramic, it's hard. So when you use a filament that has some particle inside that, it will not sort of like tear or damage this opening. Okay. Brass, even though it's metal, brass is a very, what you call, very soft metal lah. Even though it's hard by looking at this, but it's still considered as soft metal. So over time, it will wear this hole if you put a lot of particle infused filament lah. That's why people come up with this ruby. So this is from ABS. You learn about ABS. Dah pegang. Bulat sikit. This from the TPU. Pegang. Pegang. So you can buy a lot of different filament. But PLA, this PLA is the most commonly used because it's cheap. It's cheap and also easy to work lah. Okay, the TPU is like rubber. If your phone case here, if you want to change the phone case, you can use that TPU, thermoplastic urethane, in order to make that.
Assalamualaikum and good afternoon. Welcome to Industry and Engineering Lab, or what we call 3D Printing Lab. Okay, so today I will share with you what is possible with 3D printing. Okay, so as you can see, this is what possible to do with 3D printing. So nowadays, it is easy to use 3D print. You can buy, and even you have zero experience, you can print it because advancement of technology. So 2 years or 3 years ago, it is a hassle thing. You need to learn how to back leveling and so on. Nowadays, you can buy and then print. Okay, so in terms of material, there is a lot of potential in terms to advance with 3D printing. So this lab focus on parameter optimization. So we optimize the parameter, we optimize the machine to focus how to get good mechanical properties of things. But another branch of our department focus on creating new material for 3D printing. Okay, so for example, this is from Prof. Hazdin lab, material lab. So they are focusing on producing filament from durian skin, and also they I cannot remember, but they focus on mixturing different kind of polymer and lignin fiber to produce a new filament. So what it can improve? It can improve heat retention, water retention and so on. So that is one of the example lah. Okay, as you can see, this is a wood filament, so it has a texture of wood. So this is commercially available filament. So in filament that are still in research is, for example, like my research, metal filament. Okay, so by using 3D printer, you can produce fully metal like this, but it's still in phase development. Because before this, if you want to 3D print metal, you have to use a very expensive machine that use SLM or SLS technology, laser sintering. That is cost around, do you know? 1 million. Okay, so it's very expensive. But nowadays, with advancement of technology and research, we can produce a metallic structure like this, a lattice structure, or you can call it TPMS, triply periodic minimal surface structure. Okay, by using just a low cost printer like this, but it has a subsequent process lah. You have to debind and sinter and so on. So this is copper. So another metal that is still in research is inconel 718, and then stainless steel 174, stainless steel 316, and so on. So another area that growing interest is in terms of electrochemistry. So there is a 3D printed battery, 3D printed electrode that is still in research and development. So basically, you can print a porous electrode like this, and then you can study the characterization, how it collects current and so on. So there's a lot of potential for 3D printing. Okay, so another form of 3D printing. So this is called FDM, you know, right? Fuse deposition modeling. Okay, use filament. So another type of 3D printing is this, using resin. Okay, so basically it is using resin and then you cure using UV light or laser. Okay, so this is more accurate. The layer is around 0.001, so it's very fine. You cannot see the layer height. With this, it's visible because it's around 0.2. Okay, but not many people uses this because it's very tedious process. After you print, you have to clean it with PVA, alcohol, IPA, isopropyl alcohol, and then you need to cure with UV light. So it's a very tedious process, but the result is very beautiful. And is for this technology, it is not still in prototype level. So from what we visit SIRIM, Kementerian Kesihatan Malaysia, our Ministry of Health, have deployed 11 SLA machine to their clinic for dental purpose. So there's 11 clinic in Malaysia that have 3D printer to make denture. Okay, so don't think that 3D printing is just for toys and so on. So it's nowadays is used in industry also. So for high-end application like Bugatti Chiron or Bugatti Veyron, their brake also made from 3D printed, but a very expensive printer lah. Okay, so that's all sharing for me. So okay, thank you.
Before we end this, we will have some souvenir from this lab. But to get this souvenir, you need to answer some question posed by Brother Talhah. So Brother Talhah, one question.
Okay, I want to ask, who knows when is the year 3D printer was invented? Started.
Can guess. Whatever near, then get lah. Which year the 3D printer is invented? You can guess lah. Boleh, itu boleh search. Tapi cepat.
When was 3D printed?
Sama said 2020, 2016, 1984.
Okay, betul.
84. Siapa? Okay, Rifdi. Okay, so Rifdi got this cat. Okay, so next question.
Okay, just a sharing. This technology is already 40 years. Okay, so technology when it has been patented, so 30 years, other people cannot tiru or take the technology. So that's why around 2015 or 2014, there's a lot of 3D printer because the patent has expired. So other people can do open source and so on. So that's why you can see a lot of brand. Before this, only Stratasys that can produce a 3D printer. Okay, so 3D printer has been around 40 years. Okay.
Okay, I will ask one question. How do you think this is made? This one, this big one. This thing with a lot of color. How do you think it was made, and how long it take to make that thing? Whoever gives a very close answer, get the thing. How do you think we make that, and how long it take to make that? Okay, right. Sister pula, sister. Now it's sister. Just now is brother, now sister. Anyone?
Saya boleh hayau nak tahu jawapan. Berapa lama
And then how long
dengan
you take?
masa ni?
One month. Berapa month?
Okay, printing time around 60 hours. So assembly time around 1 day. So 84 hours to produce that thing.
So roughly around a week you can finish lah that thing. Okay. So yeah. Okay. Okay. Last question. Last question from Dr. Shahira. Whatever. Yeah. Ask anything. Anything. Yang you curious tanya je dia orang. Sini.
Okay, for this 3D printing just now, Mr. Talhah told us it made from? Just now. P?
What polymer?
What polymer just now it made from?
Huh?
Not.
The most common filament used. What? PLA, polylactic acid.
Okay. So got this. Okay. PLA. Kemarin dah tahu.
I will just briefly explain about the electrospinning. So this is electrospinning. It's actually a method. It's a technique. Okay? A technique where we create a micro porous scaffold from the polymeric solution. So this scaffold they have the randomly organized and continuous nanofiber. So it has a very random arrangement of nanofiber. So how? By applying the electrostatic repulsion between the surface charges of the polymeric solution. The basic setup of the electrospinning. So they have three main components, which is the spinneret, where it will hold the shrink contain the polymeric solution, and then we have the high voltage power supply, and then we have the conductive metal collector. So they have a different type of collector. We have this one is the drum rotation collector, and then we have the plate collector. So and then for the electrospinning to happen, it has three main processes. So the first one is application of the high voltage to induce the surface charge accumulate on the droplet of the polymeric solution. When we apply the high voltage to accumulate the surface charge of the solution on the droplet polymer at the needle tip. This is number one. So we apply the voltage to make sure the surface charges is on the droplet surface. So when the condition where the electric field strengthen, and then it surpasses the surface tension of the polymer. So the Coulombic force. What is Coulombic force? Is the forces that accumulate in here. They will tend to push the solution and then stretch it into push the droplet and stretch it into the Taylor cone. So this is the Taylor cone. Where you can see over there. That's the Taylor cone. And then the third process is it will eject the solution onto the collector with the different polarity. So as you can see, this is the positive charge and this is the negative charge. So that's the importance of the high voltage to ensure to inject the solution and make it elongate, become a fiber. So basically, it from the liquid state to the solid state. So this is the main three process for the electrospinning. And to make it happen, you need three main parameters, which is the solubility parameter, the solution parameter, the process parameter, and the environment parameter. So this is three important parameter, and every parameter so they have important I could say important parameters. So because under solution parameter you need to make sure the conductivity, the viscosity, the polymer concentration, and also the surface tension is in optimized condition to make sure you to get the smooth nanofiber. So, for example, like if the solution has low concentration, so it will become electrospraying, not electrospinning. So the fiber is not forming. Instead of fiber, you will get the beaded formation. So if the concentration is too high, the solution become thicker. So the solution, the viscosity also high, and the surface tension also high. So you will get clogging like this. So you will get either clogging or beaded formation. So the parameter is play important role in this electrospinning method. And then for the second parameter, which is the process. The process is where the machine it is. For example, the main one is the applied voltage. Applied voltage, you need to optimize the voltage. I mean, you need to play around with the voltage. Either the solution is suitable for the high voltage or not. And then the tip to collector distance also play important role. So the tip and the collector, this one is 10 centimeter. So if it's too distance, you will get like thin nanofiber. So if it's too close, you will get like thick nanofiber, or somehow you get the beaded because it's too close. The third parameter is the environment. Okay, the environment is temperature and humidity. So some polymer they require like cold temperature, cold condition. Some require hot, but it's too hot, too cold also is not good for the polymer, because during the elongation, during the nanofiber formation, there will be evaporate. Some solution might be evaporate and then make it like nanofiber lah. So if it's like too cold, you are afraid that the solution in the stream will clog the needle. So if too hot, it will become watery. So the temperature also play important role in the viscosity of the solution. So it will influence the viscosity of the solution. So if you can see, there's the threaded cone, and then we have like one fresh fiber. Okay, that one is.
So imagine now that thing, if you look under microscope, is full of fiber. So there are like a mesh of fiber there, and then this is useful for, let's say, you can put that as a like mass filter, because when you have a lot of fiber, nanofiber, there are very small pores. So air can in, but the material cannot go in. So that's one of the using of this electrospinning. We call this electrospinning. So you can see there, you can feel the fiber like this. So of course it looks like just a simple thing, but if you look under the microscope, very powerful microscope, then you will see the difference. Normally when you have this aluminum foil, you put under microscope, you see nothing. But there, if you put under microscope, you see like a lot of fiber, and that a lot of fiber will correspond to many advantages lah, in terms of higher surface area and so on lah. Okay, so basically this is electrospinning.
Positive charges here.
You understand? No. Why? Because if you like this one, they have a different characteristic. Some solution